Mm. Namaskar. I am Dr. Nidhi Chauhan, Assistant Professor, Department of Chemistry, Institute for Excellence in Higher Education, भोपाल. और हमारा जो आज का ई कंटेंट का टॉपिक है दैट इज टाइप्स ऑफ केमिकल बॉन्डिंग एंड वी आर डिस्कसिंग इट अंडर अ फ्लैगशिप प्रोग्राम ऑफ आवर इंस्टीट्यूट दैट इज ज्ञान मेघ. सो बीएससी सेमेस्टर 1 के अंदर जो इनऑर्गेनिक केमिस्ट्री का पेपर है इसमें वी विल बी डीलिंग विद द टॉपिक टाइप्स ऑफ केमिकल बॉन्ड्स. The topics that we will cover in this particular e-content will be introduction to chemical bonding, ionic bonding, covalent bonding, hydrogen bonding, metallic bonding. We'll be seeing the summary of all these types of bonding and we'll be seeing some references that you can refer for further reading, and we'll be seeing some assessment questions for the further knowledge of this particular topic. These are some learning outcomes that after studying this particular topic or after seeing this particular e-content, you will be able to explain the types of chemical bondings. You will be able to understand the basic concepts of ionic and covalent bonding. You will be able to understand and explain the hydrogen bonding with some of its prominent examples. Also, the students who are seeing this e-content will be able to identify the types of chemical bonding in different compounds, and also will be able to describe the metallic bonds and the metallic properties. Now, first of all, what is chemical bonding? Chemical bonding refers to the formation of chemical bond between two atoms, ions or molecules, and this bond formation gives rise to a chemical compound. Now, this bond formation can occur in two ways, either by the transfer of electrons or by the sharing of electrons. And the strength of this chemical bonds, it varies considerably. For example, there are some strong bonds which are covalent bonds, ionic bonds, metallic bonds, and then there are some weak bonds such as dipole-dipole interactions, London dispersion forces, and hydrogen bonding. So the strong bonds, basically they are the primary bond, and the weak bonds, they are also called as the secondary bonds. In this topic, we'll be dealing with some prominent type of chemical bonds such as ionic bond, covalent bond, hydrogen bonds, and metallic bonds. First of all, we'll be dealing with what is ionic bond. Ionic bond is formed by the transfer of electrons from one metal to other non-metal. So basically this ionic bond is formed between metal and non-metal. Also these ionic bonds, they tend to form the electrostatic attraction between elements whose atoms, they need to lose electrons to attain the nearest noble gas electronic configuration, and some of the atoms, they want to gain electron to achieve the noble gas electronic configuration. So basically this is a transfer of electrons from one metal to other non-metal. Also the metal which lose electrons becomes positively charged and they are called as cation, and the non-metals which gain electrons, they become negatively charged and they are called as anions. Now I will be explaining the formation of ionic bond, taking a very prominent example of NaCl, that is sodium chloride. As we all know that the atomic number of sodium is 11 and the electronic configuration is 1s2, 2s2, 2p6, 3s1. So as you can see in the slide, that the outermost shell of sodium, that is the 3s orbital, has one electron, and it has to lose that one electron to acquire the nearest noble gas electronic configuration. So what sodium does, it loses that one extra electron and it gets converted into a positive charge, that is sodium cation. Whereas on the other hand, chlorine, it acquires one extra electron from sodium atom and it gets converted into a negatively charged ion, that is chloride ion. So in both these species, we can see that the outermost shell are having the nearest noble gas electronic configurations, and in this way the formation of ionic bond takes place by the transfer of electrons between a metal and a non-metal. Now next we'll be seeing the covalent bond formation. Covalent bond is formed when the sharing of electrons takes place between two participating atoms. Or we can say that the sharing of electron takes place between two nonmetals. And this sharing can be achieved in two different ways. Either the sharing of electrons can be between atoms of same kind, for example, hydrogen, chlorine, etc., or the sharing of electrons between atoms of different kinds, for example, HCl, ammonia, water, etc. Now it is very important to note that covalent bonds are formed when orbitals containing one electron they should overlap, and the greater the overlap between the such type of bond formation, the stronger will be the strength of that bond. And atoms are held together because the nuclei, which have an overall positive charge, they are attracted towards the shared pair of electrons. So that's how the covalent bond formation takes place. Now we'll be seeing the formation of a hydrogen molecule. That is when the same kind of atoms they combine together to form a covalent bond. So a hydrogen molecule is formed by the sharing of an electron pair to form a single covalent bond. As we all know that the atomic number of hydrogen is 1 and the electronic configuration of hydrogen is 1s1. So in s orbital, it is required to have at least two electrons to get it stabilized. So what hydrogen will do, it will mutually combine or it will equally share that one electron with other hydrogen atom. So two hydrogen atoms will mutually share their one electron to form a single covalent bond, and that's how the formation of hydrogen molecule takes place. Now next is the formation of hydrogen chloride, in which chloride atom, the electronic configuration is 287, and it will be requiring one electron from a neighboring atom to complete its noble electronic gas configuration to complete its octet. And as we know that hydrogen is having one electron in its outermost shell, that is 1s1, and the electronic configuration 287 chloride is having. So what hydrogen and chlorine will do, they will mutually share one extra one electron, and will result in the formation of covalent bond formation. Then coming to the next type of bonding, that is hydrogen bonding. And hydrogen bonding arises due to the dipole-dipole interaction between a hydrogen atom that is bonded to a highly electronegative atom and another highly electronegative atom which lies in the vicinity of that particular hydrogen atom. So, for example, in water molecules, the hydrogen is covalently bonded to an electronegative atom, that is oxygen, and there will be various water molecules which will be having dipole-dipole interactions, and so hydrogen of one electronegative atom will be combining or will be forming bonding with the electronegative atom in its vicinity. So that is hydrogen bonding, and there are two prominent conditions for the formation of hydrogen bonding. Is that the molecule must contain a highly electronegative atom which is linked to the hydrogen atom, and the higher the electronegativity, we know the higher will be the polarization of the molecule. And the second condition for the formation of hydrogen bond is that size of the electronegative atom should be small. The smaller the size, the greater will be the bond formation or the attraction between the molecules. This is the example of hydrogen bonding which I have taken. As you can see in the slide, the water molecules, they are forming hydrogen bonds with each other. Hydrogen, which is linked to an electronegative atom, that is oxygen, it is forming a hydrogen bond with the other electronegative atom of water molecules which is in vicinity of that particular hydrogen atoms. So that ways the hydrogen bonds between the molecules takes place. Similarly in hydrogen fluoride, because fluorine we know it is the highest electronegative element and it is having small size, the bonding, so the bonding between the hydrogen and fluorine, it will be extremely polar and it will result in the strong bond formation. So that's how we can explain the formation of hydrogen bond in water molecule and hydrogen fluoride. Then lastly be dealing with the metallic bond. So metallic bond is formed when a group of metal atoms shares a cloud of valence electrons. And therefore a metallic bond is a bond that holds atoms together in a metallic substance. So valence electrons are relatively free to move in a metallic substance throughout the entire crystals, and the atoms which the electrons leave behind, it becomes a positively charged lattice. The lattice basically involves a positive charge surrounded by the delocalized electrons. Now it is very important to note the metallic properties because the electrons are continuously moving in a metal, and when the electrons after leaving a certain place they move to some other place leaving behind the positive charge. So therefore metals are good conductors of electricity, and the metals can have their shape change relatively. They are having the properties of malleability and ductility. Malleable means they can be hammered into sheets, and ductiles means they can be drawn into rods and wires. Due to this free movement of electrons, because continuously the electrons are mobile and they are moving, so this is a very prominent property of the metal, that they are very good conductors of electricity, and they are malleable, they are ductile, they outshine, and certain other metallic properties are associated with this. Then we'll be seeing the summary of types of chemicals bonds. As already discussed, we have seen ionic bonding, which is formed by the transfer of electrons between a metal and non-metal, and we have seen the example of sodium chloride into that. Then comes the covalent bonding, which is formed by the mutual sharing of electron between two non-metals. For example, ammonia molecule is there, then the formation of hydrogen chloride, water, etc. is there. Third, there is hydrogen bond, and the hydrogen of one electronegative atom, it attracts to the electronegative atoms that are found in the vicinity of that particular hydrogen atom. And we have seen two prominent examples of these, water molecule and HF is the example of hydrogen bonding. And then lastly, there is metallic bonding, the bonds between the atoms of the metals that hold together, it is called as metallic bond. These are some references which you can refer for further reading of this topic. Now it's time to assess yourself. A chemical bonding between two atoms which share a single pair of electron is. When a single pair of electron will be shared between two atoms, then obviously this is an example of covalent bonding, and a single covalent bond will be formed. Then coming to the next MCQ question, a chemical bond formation that involves the complete transfer of electrons between atoms is, so I have already discussed in ionic bonding, that ionic bonding occurs between when there is a transfer of electrons when metals between the metals and non-metals. So the right answer for this is ionic bond. Then the next question is which of the following molecule can form a hydrogen bond with hydrogen? And the correct answer is oxygen, as I have already mentioned in the formation of hydrogen bonding, that it bonds with the strongly electronegative atom that is associated with hydrogen. And out of these options, you can see oxygen is the only one electronegative atom. So hydrogen on bonding with oxygen, that is the formation of water molecule, it will give rise to the formation of hydrogen bond. Thank you.